Let's complete this given k-list table in such a way that our star operation be a commutative binary operation. The first thing we need to consider here is the idea that the operation star should be a binary operation. That is, number one, we need to make sure that per our given set containing the elements A, B, C, and D operated to the same elements, all of the entries here must be or within the same set. That would mean all the entries here would also be A, B, C, and D. That would mean, again, for all the unknown entries here, we can only use A, B, C, and D so that it would be a binary operation because we need to come up with a closure property. And number two is the idea of commutativity. Commutativity tells us that if we have the operation A star B, the same result would happen if you're going to operate B star A. This would mean that our table here should also illustrate that. But we already have a strategy in the previous video in determining whether a certain k-list table is commutative or not, using this diagonal here, okay? Because the entries on this diagonal are actually the results when we operate with the element to itself, such as A star A, B star B, C star C, and D star C. That would mean that's the same value because if you're going to interchange A and A for A star A, it's just the same. After this, we would know that it's a commutative binary operation if the corresponding entries will follow like this. We have here B, C, blank, right? On the other side here, we have B on its next column, B, C, D. To make sure that this is a commutative or this k-list table is a result of a commutative binary operation, the same entry should also be in this first row. That would mean it would be given that the result here should be D because it's B, C, D here. Conversely, or also accordingly, that would mean that for the next row, it would be corresponded to our next column, A blank, blank C. That would mean this would be A and this should be C. Okay? And finally, for our last entry here, we have B and B here as well. If we're going to use these entries, that would tell us that the complete k-list table is a commutative binary operation. Of course, we're going to illustrate it here as well. Let's try to come up or use the original k-list table. Okay? And of course, that's one strategy. I'm just showing you the two different methods so that you could pick your own later. So we know that we would like to solve for this entry first. That would mean we are solving for the result if we are going to operate A and D on the same operation star. Because A, that's our row and column of D. But again, this should be equal to D star A so that it should be commutative. And D star A is this result. D, this is our row, and A, this is our column. The result is D. And as mentioned earlier, this should also be the same entry in our unknown portion of the table. Because A star D, or I mean D star A, let me have it here. Because D star A is equal to D, this would mean that A star D should also be D. So let me use red here for our final answer for our k-list table, to which is also the same result as earlier, D. Okay. The next here is, let's find out the entry of this. Okay. This is actually the result when we are going to operate B and C. So we have here B star C. For this to be commutative, this should be the same as C star B. And C star B can be found here. C is our column, R in a row, and B is our column. The result here is A. So that would mean, since C star B is equal to A, this should also be the result of B star C, giving us the result for B star C. This would be our A. Next would be this entry here. This is actually D star B, right? Because we have here D star B. So let's have D star B, which will be the same as B star D. And B star D is B, we have here, and we have this D here. The intersection is C. This would mean the entry here should also be C. So, since B star D is C, D star B should also be C. So we have this entry here, C. And finally, for this entry here, this is D star C. Okay, we have D star C. Let me use this portion here. D star C must be the same as C star D. And C star D is this here and this column. The intersection is B. Okay, so that would mean that the operation for the result for C star D is B. This should also be the result for D star C, so that the resulting operation is a commutative binary operation. This would be our final answer here. As mentioned earlier, checking using this column, diagonal here, using this diagonal, we have BCD, BCD, AC, AC, B, and B. At this time, we are now verified that our table, or our star, using this given KDS table, our star operation is a commutative binary operation. So this is how we solve for, or to complete a table. We could use the idea of the diagonal, and of course you could also have these methods. Thank you very much for watching.